This is the Vika Academy. If you have not subscribed to the channel, kindly subscribe. Share also with your friends. Share also with your friends so that every time I post anything here, they are the first one to get notification. So today we are looking at openness of union and intersection of collection of sets. This is very key in introduction to data analysis or in general in data analysis. Again, don't forget to subscribe and share to your friends also, so that they help in getting this in case they are doing the revision and ending Spartan's education. So let's look at this union. The union of arbitrary collection of sets is open set. The intersection of finite collection of set is also open. So here you have to remember one thing. What do we mean by open set? We need to remember that we need a P in a given interval AB, and this will be in a given subset, as for example. So that's the key basic knowledge that you need to remember in this. So because we are talking about union, so we need to introduce union in this case. So we let U be a union of collection of open sets. This is a proof of this symbol theory, which is very key. So U, we let this U be given and that where A is open for each alpha. Obvious, it will be trivial if we say U is empty set. That means is union for M set, you find that it will be automatically be open because every area will be there, the neighborhood will be inside the neighborhood, so every point will be the neighborhood of each other. But if it's not empty, there must be a x in it, such that if this, then that x is in A alpha for a given interval, then since A alpha by definition here is open, then it will mean there exists a given interval MB such that this is true. That's a key definition of neighborhood. Which will imply that since this is in that A alpha is in the union, then it will mean this will be true, and therefore it will mean U is a neighborhood of X, and we should mean that since X is arbitrary, it will imply that U is open, and ends the proof of the first part, Okay, let's look about how we look at intersection part. So we let this collection be a finite collection of open set. So what you need to do is to show that and B, which is the intersection of all hairs, is actually open. If we made that, then we know that all finite collections of open sets are open. So suppose that B is not empty, because if it's open, it becomes trivial. So we let X be in B, so that means not empty, and it means that X is now in the I's for all highs, and since A high is open by our definition here, is open, then there exists an interval MB such that element is in that and it's also contained to that. That shows neighborhood, and because neighborhood have been fulfilled, like so neighborhood, the condition of neighborhood is fulfilled, it will mean that B is open, and ends the proof of the theory. So kindly subscribe if you have not yet subscribed, and share with your friends.